ช่วงนี้คออักเสบหมดแล้วนะครับ ก็จะพยายามพูดให้รู้เรื่องนะครับโอเคI should join อันนี้นะครับ Let me share you your slide โอเคโอเคนะครับum, so continue from the last lecture นะครับ we had lecture number 4 นะครับ which is about functions นะครับ so you probably have a concept of how function works. The important thing that related to the function is that you know the basic definition of functionนะครับ, and you can also differentiate functions and relations because as we know all the functions are relation but some of the relation are not function, right? So you should be able to differentiate this is one is a function and this one is not a function and it is a relation. So the next topic that we're going to discuss is um, on a topic called logic. Most of you probably have heard, or I'm pretty sure that you have studied some kind of logic in your high school or maybe in your middle school already. In Thai, we call it takasat, right? But in in English, we call it logic, which I have divided logic topics into two parts. The first part will be in lecture 5. This one will be basically, well, I would call it the basic logic of, of everything. Okay, you will know like the notation, the definition of logics, and you see a lot of examples of logics. Okay. The second part will be in lecture 6. Okay, so that one will be more of an advanced topic in logics. Okay, it will be mostly related to a, a topic called predicate logic, which is basically you have a different scenario than a normal logic. Okay, a you have to be able to tell whether or not this sentence, which in the lecture 5 is not a logic sentence, and in lecture 6 you have to be able to tell if it's a sentence that can be told a truth or false. Okay, so that's how we're going to structure logic. Lecture 5 basic, lecture 6 advanced. Okay, so in lecture 5 we'll discuss something that called propositional logic. Okay, so basically, like um, you probably have used logic in everyday lives, in everything. Basically, when you do make your decision, you usually have to logic yourself to choose or to to choose what to buy, to choose what to eat, to choose what to dress. Okay, all these involve logic in some way or another. A little bit, maybe some decision you might have to make argument, or you have to involve a lot of logic into your decision, right? For example, if you want to choose what to wear today, you probably have some kind of logic, but maybe not much, right? Maybe okay, today is Wednesday. Wednesday is the color Wednesday green, maybe like so. Maybe I will wear something that related to green. That's logic, right? Or something bigger, like if you want to buy a car, okay, you have to logically think about, okay, how can I afford this? How much money do I need? How long can I pay for this and all that, right? What am I going to use it for? Is it worth it buying it now or wait? All these kind of questions, okay, you have to use your logic to make your decision. To whether it's big decision with small decision, mostly involved with logic. So you use your logics in everyday life. Okay? The system that we're going to discuss here, trying to system, trying to put a system into your logic world. Okay, you will have a sentence, you will have a reasons, and you have a result, which is how can you use your logics to conclude that the result is true. Okay, that's what logic is for. Okay, so you have to use your reason. Reason is logics. Okay, if you know this one, this reason is very important. It's true. This one is less important, and it's maybe not true, and all this combined it into final decision. Okay, that's how we're gonna learn in this logic topic. Okay, um, so surprisingly, logic has not been invented for that long. Okay, um, people always think of, when you make decision, when you communicate with people, right? When you say something, right? Um, Sometimes using languages are difficult to interpret it, whether it's what's the meaning, that what's the actual meaning of the sentence that you just said, right? For example, um, for example, in Thai, right? You can say, um, um, ผมว่ายน้ำ right? ผมว่ายน้ำ Some people might interpret that as I swim in water, right? Some people might interpret that as I, pay respect, to a person called Nam, or even I pay respect to some, river. You can always do that, right? As well, right? So language, the problem is that it's ambiguous. It's not clear. Sometimes you have a different meanings for different people, so you cannot tell whether it's true or it's false, right? So what you want is you want a system that everyone, whether it's someone who never seen your system or you never ever seen your statements before, can come in and read the sentence and can understand the sentence the same for everyone. Okay, so logic will help you do that. Okay, logic will will, will convert a system of languages, of sentences, into a system of a logic sentences that will make it, that will help you build your, logic system, that will help you build your reasoning system, that will probably eventually help you create a solid, or you will probably learn how to create a solid or a valid argument or a valid result. Okay, so that's how logic can comes in. Okay, language are ambiguous, it's sometimes confusing, so logic can help that. It build the system into a system that not ambiguous at all. Okay, so what are we going to study today? Can be anything, but we will mostly, well, most of the example, because it's easier, we talk about a lot of mathematical statement, like equation, like, mathematical expression. Okay, so that one, it's easy to read, it's easy to write, and it's easy to understand. Okay, practical of logic, you probably have used logic in everyday life. Other than that, you can also use it to design a computer machine, of course. You know, um, you probably have heard of a CPU, right? Inside CPU, it's control a lot of the smallest or the tiniest unit inside the CPU is something that There's something that is um, it's called logical unit. Okay, it can be one or zero basically. Okay, which is translated back into logic, which means it's one is true, zero is false, right? So you can use that as a basic to design a computer machine. Basically, you can do specification system. Okay, maybe you never, but like you have to if you have to design a system, something, a system of uh, uh, school lunch, for example, you can use that logic to argue, to make some decision. Of course, AI is another topic that use a lot of logic. Okay. Computer programming, of course, you have do some computer programming, right? Inside your Python, you have if statement, right? You have loop statements, right? You have why, do why for, you have if else, if else, if else, you have switch case. All these are logics, okay? In if and if else, in why and do why, you have this what you call is the conditional statement, right? That's where the loop or the if will determine whether to do the next set statement or to skip and do the other statement, right? And all that, right? So we mostly use this to prove it theorem. Well, not really proving, but okay. So this is the example. So sorry, this is a joke where you can see that there's an older man. He's probably like a senior professor, and so there's a younger man wearing glasses, probably like a younger or a junior teacher or something, or maybe even his student, right? And then they do something, I don't know, proving or a math solving, problem solving on a blackboard there, and then they're kind of like doing some works there, and then you can see the result on the right, right? So instead of explaining things, how you get your results, the the younger man is saying, then a miracle occurs. Okay, well, that's sometimes happen, but you know, like he just saying that, then a miracle occurs, and then the result appears, right? So the senior professor just comment, I think you should be more explicit here in the step two. So is that funny? Yeah, maybe not. But I mean, like he comes up with maybe a correct answer, but I don't know. He just doesn't give a reason of how you come up with the correct answer. He just said that a miracle occurs. Okay, so that which is quite funny for me at least. Um, okay, so in logic, we are building the system. Okay, building our system inside the system. Outside, anything outside, we're not consider. We will only consider something that is in the system. Okay. So in this system, let's say this system is called a propositional logic system. Okay. So the basic or the most crucial elements in the propositional logic system is a statement or a proposition. Okay. So in this system, you have a lot of statements or a proposition. Okay. Now the proposition or statement is just like your normal. It can be anything. It can be a mathematical equation. It can be you saying some sentences. Okay. But the important properties of a propositional is you have to be able to tell whether it's true, not true, sorry, whether it's true or false. Okay. Any sentence that cannot be concluded whether it's true or false is not proposition. Okay, we will not include these sentence in our system. Okay, so we will only include every sentence, every statements, every proposition that are able to tell it's true or false. Okay, for example, for example, uh, 1 to 7 out here. These are all statements, okay, but not every. These are like sentence, right? But not everyone are a proposition. What we have to do is we have to check if it can, if it is true or false. But if you cannot determine whether it's true or false, it's not proposition. Okay. The first one. You have square root 2 greater than 1. Okay. Is this proposition? Is this proposition? You can also answer in your chat if you want to. I mean, if you want to join. But I'll keep talking, and then since we have less time, I'm probably not going to ask one more. Okay. But first one, square root 2 is greater than 1. Is this one sentence? Okay. It's a mathematical sentence, right? Square root 2 is greater than 1. So the problem is asking, is this one proposition? So you have to go back to the definition of proposition. The proposition is a sentence that is true or false, but not both. Okay. So can you tell if square root 2 is greater than 1 true or false? Anyone? Well, probably most of you who didn't answer, most of you probably can tell that this one is true, right? Yeah, I mean, square root 2 is 1 point something, right? Which is definitely greater than 1, right? So, since you can tell that this statement is true, this one is proposition. So, I'm just going to write circle for proposition. Okay. So, that's the first one. True. ขอบคุณมากครับอุณอัชรนันท์ the second one is the second one, which is 1 plus 1 equal to 1 proposition. Is this proposition?
Yes.
Yes. Oh, who answered that?
เม
Excellent.
ทัศน์
คุณครับมูลเมทัศน์นะครับ thank you
ครับ
thank you. I kind of skipped the step a little bit because I kind of want to know if you can, you know, analyze the problem and answer that by yourself. Similar to the first one, you have to check in order for 1 plus 1 to be equal to 1 to be a statement or a proposition. You have to be able to tell whether it's true or false, right? Some people might be, but Ajahn have 1 plus 1 equal to 1 is not correct, right? Most of you probably say that. But I don't care whether it's correct or not. The only thing that I care if it's true or false, which in this case is clearly this one is false, right? Of course, 1 plus 1 is not going to be equal to 1. Right? It's false, right? So it's false. So when you can tell it's false, it is a proposition. Okay. Uh, uh, can you see where I'm going? Okay. The third one is a little bit harder. Some people might not agree with me, but let's see. So pig can fly. Pig can fly. Okay. Is this proposition? Anyone trying to? Anyone trying? What might? Oh, false. Maybe. Kun Acharanan answer in the chat. False. Maybe. Okay. So what does that mean? False. Maybe. So pig can fly. Meaning what? Meaning all the pig, right, can fly, right? So when people say that pig can fly, what does it mean? Is this a statement true or is this statement false? Or
It's
50%
false.
true 50%คุณเชิญครับคุณเมทัศน์
It is false. This statement is false.
อ่าขอบคุณครับ thank you อ่ะ two kind of different approach of how to answer this one คุณเมทัศน์ said this one is false ครับ which is correct but คุณอัชรานันท์ said fell 50% true 50% which is okay. So if we consider the answer of Kun Metatนะครับ Kun Metat said this statement is false. So this sentence will immediately become proposition, right? Because we only care if it's true or false, right? So if you can tell, oh, this one is false. So pig can fly will be proposition. But according to Kun Achalanan, not Achalawan, no Achalanan. Sorry if I read it incorrectly. Pick and fly, she said, for 50% true, 50%, which means that you cannot tell whether it's true or false, right? So according to Kun Achalanan, this one is not proposition, right? So I don't know if you remember when you uh, go back to relation or a function, when you tell if you have one sentence, if you want to say this one is true or this one is false, how do we do it? Okay, if you have a sentence, it will be true when let's say like human is immortal. Let's say human is okay. Let's say human is nice. Let's. So this one will be true if every human, right? Usually when we don't say which human, right? But we say human is nice, which means that every human is nice. Which means that if it's true, everyone has to be nice, right? But this one will be false if there's one person that is not nice at all, right? You see similar here? So pig and fly, similar thing. Pig and fly will be true if all the pigs can fly, right? Which is, of course, not true at all because in the opposite way, actually, I don't think there's any pig that can fly, right? But so this one is definitely false, false. You can tell unless there is one pig. Well, one pig can fly still make this statement false, okay? Because you have to make all the pigs can fly. So this one also proposition because it's false. Okay. It's kind of look easy, but it's kind of quite deep. You have to make some analyze. Okay. The fourth one. What time is it? I think most of you probably can answer. Is this one proposition? Well, okay. Well, because what time is it? Is it true or is it false? Oh,คุณเมธ answer in the chat นะครับคุณอิสริยา false false โอเคคุณเมทัศน์ answer not proposition very good คุณอิสริยา answer false thank you นะครับ first answer but okay so what time is it false I'm not sure do you mean like that like this sentence is proposition is false or what time is it is false มันต่างกันนะครับเรากำลัง false ว่าอะไร false ว่า what time is it เป็น proposition เป็น false หรือว่า what time is it is false well what time is it is actually a question right so you cannot tell well I mean there's no truth value in that right you cannot what time is it what does that mean right? It's 11 o'clock right? So this one you cannot really tell right mm, not false or true at all I mean there's no truth in that it's just a question right so this one is not propositionนะครับ. It's a question you cannot tell it's true or false The fifth one, the fifth one, okay. This one is a mathematical expression. 5 to the power 3 plus 7 to the power 2 divided by square root 2 plus 3. Is this proposition? Anyone want to try to guess? Well, you have to ask yourself, is this true or is this false? Hmm. It's Salia. Answer, not true, false or true. Yes, because it just some number, right? Added together, multiply them together. There is no truth in that. You know what I mean? You cannot tell whether it's true or false. It's just some number add together. So this one, you cannot tell. Not at all true or false. So this one, another one that is not proposition. Okay. The sixth one, x plus one. This one difficult, but I mean, trying to think, try to reason. Okay. Okay. X plus one equal to two. X plus 1 equal to 2. Is this proposition? Hmm. Anyone try? Anyone want to guess? False again. False again. Thank you for your answer นะครับ but imagine this. This one you cannot tell. Well, um, if I ask you this one is true or false. Can you really tell it's true or false? You cannot really tell, right? Because unless you know the value of x, right? So let's say x is 1, it's going to be true, right? But if x is something else, this one will be false, right? So can you tell now without x value, you cannot tell, right? Yes. So unless you know the value of x, x plus 1 equal to 2, you cannot tell. So this one is not similar to 7. Okay, so I'm going to go for 7. X plus y greater than 0. Unless you know the value of x and y, you will not be able to tell if it's true or false. So this one is also not a proposition. Okay, these and the oh, sorry, these kind of sentence, the number 6 and number 7, this one will be in predicate logic. This one will be in lecture 6. So what if we want to determine if it's true or false? How do we do it? This one will be discussed in lecture 6. So, but for now, it will not include in our system. It will, be outside. Okay, only sentence like 1, 2, and 3 will be included in our system. Okay, these are called proposition. Okay. Um, so let's learn a little bit of notation. Okay. So because if we have to write the sentence every time, it might be awkward or maybe taking some time. So we usually use a symbol to represent a sentence or a proposition. So we might say square root 2 greater than 1 is represented with a symbol p. Okay, we will use a small cap letter to represent a proposition, and we usually start with p, q, r, s, t, and so on and so forth. Well, obvious start with p because it's represent proposition, right? P proposition. So usually, so the first proposition would be p, the second would be q, and so on, right? So we use small English letter to represent proposition, p, q, r, s, up and to whatever you want. Okay, and we usually use a capital T and capital F to represent the true value, true and false. Okay, true and false. Okay, when you see the cap T, still definitely mean true, and if you see the capital F, mean false. Okay. Now, the sentence that we have seen, like square root 2 is greater than 1. That one is what we call a atomic proposition. Okay? Those these sentence, this in 1, 2, 3, these are propositions, and because some proposition you can kind of like divide it into two or more parts or more propositions, but some proposition you cannot divide it anymore. For example, sorry to flip back and forth. For example, uh, Peter hate Lewis. Okay, Peter hates Lewis. Okay, this one, this one taken from a Family Guy, right? You know that Peter loves Lewis, right? So Peter hates Lewis, it's false. And so this is a proposition. But imagine if you have to divide this into two sentences. I don't know how you Peter and hate Lewis. Does it make another proposition, another two proposition? No, right? Because Peter, still you cannot tell whether it's true or false. Again, hate Lewis. It's who hate Lewis, right? So you cannot tell whether it's true or false, right? Similarly, square root 2 is greater than 1 is also atomic proposition, which means that you cannot divide it anymore. You cannot split them and then say, oh, square root 2 is atomic proposition, greater than 1 is atomic proposition. No, right? It is raining outside. This one is also atomic proposition. Right? Example, well, I haven't, so example of not atomic. For example, um, today is Wednesday and I'm going to the mall, for example, right? So for this example, you can clearly see that if I divide the sentence into today is Wednesday and I'm going to the mall, you have two propositions, right? So these sentence together also a proposition. Today is Wednesday and I'm going to the mall is also a proposition because today is Wednesday is true, and I'm going to the mall is also true because I'm probably going to the mall. But together they are one proposition. But if you split them, they also have two separate propositions. So this one is called this one is called compound proposition, right? So you have atomic and then you conjoin them with with and, with or, with imply, and with equivalent, or if and only if, right? So compound proposition is basically you join atomic proposition with this not, and, or, imply, and this one is actually if and only if, or you can say equivalent, right? For example, you have P proposition P and proposition Q. You have negation of P, not P, imply Q or R or something, right? These are compound proposition. Okay. Any questions so far? No. Let's keep going. So you probably have learned this table. Yes. um, this is what is this? What is this? Is this is a truth table, right? In Thai, it's like ตารางค่าความจริง, right? Truth table, right? Table of truth. So this one is basically a tool for you to display all possible truth values of some expression that you want to examine. For example, this truth table is showing all the truth value of all the compound propositions. Okay, negation of P. Sorry, negation of P, P and Q, P or Q. Okay, let's say P and Q are atomic proposition. Okay, and then they join it with this logical operator. P imply Q. P if and only if Q, or you can say P equivalent to Q. Okay, and the last one is P exclusive or Q. Okay, so in order to display or to show all the possible truth values that, because you have, for example, let's say P and Q, right? You have P and you have Q. So P, the possible the possible value of truth that P can be is true and false, right? Q similarly, true and false. So you have four possible outcome, four possible combination of P and Q. Right? P can be true, Q can be true, P can be false, Q can be true, and true, 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 false, false, true, false, false. So that's why this table is created, because you have this column for atomic proposition, P and Q, and it lists all possible combination of the true value of P and Q, right? True, 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 false, false, true, false, false. And then this one is the next columns is list possible or the list the truth values of that expression, right? Of that of that compound proposition. So if you have P then true is true, negation of P is false, right? If you have P is true, negation of P is false, and so on. Yeah, P and P, I mean P and Q, um, P is true, Q is true, then you have P and Q true, you have P is false, Q is false, I mean P is, P is true, Q is false, you have P and Q is false. Right? Again, you don't have to remember all this table. Okay? Some people may ask, do I have to remember all this? You don't have to. Okay? Because I don't remember them either. But maybe it's maybe you can remember something that's special about it. For example, for negation for operation n, right? You will only have true when P and Q are also true, right? So this one, that's why I highlighted in red font. And then similarly for or, you have false when both of them P and Q are false, right? The rest will be true. And P imply Q, everything is true except when P is true and Q is false. You get false. Okay. And then if you have the even or if or equivalent, if you have the truth value of P and Q, uh, uh, P, the truth value of P is the same as the truth value of Q, you have true. But if the truth value of P is different than the truth value of Q, you have false. Right? That's why you have true, false, false, true. Similarly, well, oppositely, P exclusive Q is that if you have a true value of P same as Q, you get false. If you have true value of P different from the true value of Q, you get true. That's why you have false, true, true, false. Right? But I mean, this table you don't have to remember. I mean, in the exam, you will also have to you will be able to open this and then read and then find out. Okay, okay we have okay. Usually when I do this 2, 3, 4 slides from now, when I do it with a a computer engineering degree, the students, they usually have a problem understand this because maybe they don't get the English meaning of this sentence, but I'm pretty sure you can. Okay, let's say if you, well, so, as I said earlier, okay, if you have a sentence that is proposition and you want to bring them into a system of logic, a propositional logic, you might want to represent them with a symbol, right? Because writing sentence every time is not fun. So this slide is giving you an example of how you can translate your propositional sentence from a English into a logical or propositional symbols. Okay, for example, if you have a sentence, say, if it rains tomorrow, then I will not go to school. Okay. First, you have to read and then think of yourself, oh, this one is this atomic? Because if it's atomic, you just use one symbol and that's it, right? But you can see that if it rains tomorrow, then I will not go to school. I gave you a hint, right? I pause. So this one seem to be two sentence connected with some kind of connector. In this case, is imply, right? So there's two sentence, right? One is the it rains tomorrow, and the other one is I will not go to school. So how to represent this in symbol? Well, since you know that there are two sentences, you're gonna use two symbol, right? You can use one for P, P for the first sentence, and Q maybe for the second sentence. Okay, and then because this one is using a if and then, right? If and then. So according to the logical operator, this one is perfectly um, aligned with if then imply, right? Imply symbol. If P then Q, right? If P then Q. Now, usually when I represent a negation sentence, not sentence, negation sentence, yeah, like this one, not. I usually make the sentence a a non what do you call it? A not a positive sentence first, a not negation sentence first, and then I would add the negation symbol instead. So I would do P to represent it rains tomorrow, and then I will go Q, I go to school tomorrow. And then on my sentence, on my symbol, I would do P imply negation of Q. Okay. Because I want when I read it back later, I want to know that there is a negation or not in there. That's why I use Q to be I go to school, and then I added the negation symbol later, right? So that I can do, oh, this one there's negation in there. Okay. Any question so far? Okay. The second, um, I computer engineering students always have problem with this one because they don't understand what is nor mean. Okay? This one is it is neither hot nor sunny. Okay, it is neither hot nor sunny. Now you have to think, oh, is this atomic or is this compound, right? Uh, Most of you probably answer, oh, it's compound ครับอาจารย์ Combine two sentences. The first one is it is not hot, and the second one is it is not sunny, right? This one is it it is not hot, right? And it is not sunny, right? Combine two sentences with so this the sentence is like it is neither nor, which means that together. So I will choose an operation for this one because you have to combine them together. Okay, and similar to the I go to school example, because this one it has a negative meaning on both sentence, the not. So I would use H as it is hot and S as it is sunny. Okay, and then I will do negation of H and negation of S. Okay. The last one, the most difficult one, because the symbol is, I mean, the statement is so simple. Zero, how do you read this? We usually read it like zero. I mean, how do you read this? X is greater than zero and less than or equal to three, right? X is, how I say, X is less than zero and X is, wait. x is greater than 0, sorry, and x is less than or x is equal to 3, right? That's how you usually read it. X is greater than 0 and x is less than 3 or x is equal to 3. Yeah. Well, x is less than or equal to 3. So basically, I'm just writing x is okay. This is how usually you read it, right? So you can see if you read it, you see that there are three sentences in there, right? X greater than 0, x is less than 3, and x is equal to 3, right? Three separate sentence in there. Okay, so you can represent each one of them with P, Q, R. P as x greater than 0, Q is x is less than 3, and R is x is equal to 3. And you have to combine them with some logical operators. You can see this one you can use and, this one you can use or. Yes. So you would have P, and Q, or R. You actually don't have a bracket, but bracket make it more tidy. Okay, so you have P, and Q, or R, right? Any question on this one? Hey. Um, this one just saying that the it's a well formed formulas meanings that formulas mean this one is just proposition. Okay. Well, sometimes it's called formulas because of the symbols that are combined together. So well formed formula is basically that saying that not every symbols or every formulas that you formed or you converted from the proposition will be good. For example, P negation, right? This one is not valid or is not well formed. Okay, this one is not good. Okay, this one Q imply or if Q then or this one not good either, right? You can only allow if then only between two symbols, right? P imply Q, something like that. This one is okay, right? Negation of P. But this one basically, if you remember, if you have negation and negation, it cancel out. Just like when we say, "I'm not going to the mall," for example, right? I'm not going. So it's like negate of negate. It cancel out, right? So this one basically just saying that negation of P. But sometimes it doesn't. You should, even though this one is correct, it's not wrong. You can do it, but you shouldn't do it. I mean, you should always simplify it to the smallest or to the simplest form you can, right? So this one you can just cut two negation out, right? The last one, P imply Q or P imply Q. This one is not valid, right? The reason I say it's not valid because, or it's not well formed, because when you write it like this, there is some confusion because do you want to do P imply Q first and then P imply Q at the back and then put them all together? Or do you want to do Q or P first and then P imply Q or P and then the rest is implied with Q? Okay. It's kind of confusing, right? And if you do it different way, the result might be different from you do it another way, right? So this one is not well formed. You should always put brackets into. If you want to do like this, then put bracket like this. Okay. Any question for that? Okay. We should we, we should do some quizzing a little bit just to kind of like take a little break. Okay, let me load it up. Um, where is ooh, I don't know. Maybe. Uh, Um, let's do a little bit of uh, quizy. Okay. Oh, I have to restart this one. Right. Okay, I hope everyone still have remember how to join Quizy. Let's join it. Do I share screen? Oh, my bad. Okay. Now you can join joinmyquiz.com. Okay, and you enter the game code. Okay, and then you can wait a bit. Again, anyone who joined the quiz get a participation point for uh, every time we have a quiz in class, right? So please do join. Even if you answer incorrectly, that's fine. Okay. And please, please rename when you join with your first name uh, and your ID number so that I can map back. It's yeah. Can you change to? Can you put in your ID number? Well, I mean that's. If you can, that's okay. I think I can map you with your name. โอเคได้ทีแล้วนะครับเรา wait for one more one more minute maybe for everyone to join in okay 10 seconds okay, I think that should do it okay let's do
สักครู่ครับอาจารย์เข้าไม่ได้ครับ
oh okay let's I'll wait for a bit more นะครับ I think oh still some more okay Thirty one. Oh, still 32. Okay, wait a bit more. Ah, it's kind of stop now. Okay. Oh, okay. I think that's everyone who wants to join. You can start now. Well, if you still want to join, you can join during the. Don't look at my screen. Okay, go look at your question and then choose it. If I only like sandwiches with and bacon, do I like bacon sandwiches? Ooh. Yes. No. It depends. Okay. If I like sandwiches with egg and you can see it, the question stressed with the operation and right and bacon. Do I like bacon sandwiches? Most of you answer yes, but remember that and means that you have to be. It means that if you read carefully, if I only like sandwiches with egg and bacon, and bacon, so it's not egg or bacon, right? So do I like bacon sandwiches? The answer is no. Okay. So most of oh wow, some of you got it correct. So let's do the next question. Okay, now you know how to answer, right? So this one, if I like brown bread, oh, no. Ooh, okay, yes. So this one, this one say, if I like brown bread or white bread sandwiches, do I like tuna on white bread sandwiches? Right. The answer is well because he like brown or white, right? So it's either brown or white. So it's the answer is yes. Okay, so most of you got it correctly. Yes, well done. Okay. So or can be like either, right? I will go to the party. Time's up. So this one say, I will go to the party if Billy. Oh, leaderboard first. Okay, let's see. Oh, Kuntitawat is leading. Okay, this one say, I will go to the party if Billy or Bob are there, right? So it's or, right? So the question is, will I go if only Billy is there? Well, of course, it's using or. So either Billy or Bob's are there, I will go. So the answer is yes. Okay. My question is, We have to maybe hurry up. There's 10 questions. What does ambiguity mean? Well, we already discussed it, right? Languages are ambiguity. Okay, let's see the leaderboard. Ooh, the leader has swapped. Hey, so what does that mean? Okay, so definitely not using two hands, being clear. Well, that's the opposite of the ambiguity mean, right? The ambiguity mean not being clear, right? So language, the Thai language, English languages, Thai language, English language is not clear, right? Sometimes, the example I gave you, like ผมว่ายน้ำ right? What does that mean? ผมว่ายน้ำ I'm swimming in the water, or I'm paying respect to someone named Nam. Yeah. So that ambiguity means. Next one. This one, I haven't show you the logic, but I'm sure you, from the Venn diagram that we learned about sets, I think you can tell. So the red part, what does it mean? Okay, let's see the leaderboard. Oh, no swap. Okay. So this one asks, which logic word does this represent? So you have two circles, partly joined, you know, and then the color red is the area that we discussed, or the area that we chosen if this operation is chosen. So it means that it has to be true on both sides, right? So this one definitely and. I think most of you have learned this in your high school class already. So most of you got it correctly. So well done. So which logic does this represent? So this one, oh, let's see the leaderboard update. Oh, slide adjust. Okay. So this one is, you have again two circles. The area that we chosen is every area, right? Basically everything. So this one is or, right? So either A or B, either one or two, right? So it's or. Okay. So some of you answer XOR. XOR is the opposite of OR, right? As I show in the table earlier in the slide. So next one. Ah, this one harder. Ah, leaderboard again. Oh, there's a change in the leader. Okay, this one. maybe a little bit difficult, okay? But I think you can eliminate some choices. Definitely, the area that we're looking at is the area that definitely not and, right? And definitely not or, and definitely not, right? Yeah. Not means that probably if it's the answer is not, probably outside the rest, not in the circle at all, but outside. So X or mean that it has to be either it has to be outside. It's not the one that join. You can say XOR as a negation of A and B, and that's the XOR. So the next question, this one hard. Okay, let's see. Ooh, okay, this one, this one hard because well, you have to analyze a lot of things. Okay? So let's say if I only enjoy comedy TV shows or TV shows about police, but not police comedy TV show, what type of logical operator expression expresses that? Okay, if you draw a circle, one is representing the TV, a comedy TV show, and the other one is a circle representing TV show about police. Okay, and then you put them together. Okay, this one, the sentence that they explain is exactly like the last question, which means that comedy TV show and TV show about police, but not TV show about comedy TV show about police. Okay, so it's the area that is not in the middle that join together, but the area that outside either the comedy TV show that is not police and the TV show about police that is not comedy show. So XOR is the answer in this one. Well done, well done. Okay. So next question. You're a lot you're a lot better than I thought you guys would do. So well done. Last two problem. Ooh, this one is outside. Outside. The area is outside the circle, which I probably accidentally gave you the answer earlier already. For those of you who care about the score and this, okay, the faster you answer, the more score, the more points you get. Okay, but obviously you have to answer it correctly first. But then if you answer it correctly, the faster you get more points. Faster, the more you get. Ooh, okay. So this one, oh wait, I haven't answered this one. Actually, oh, okay. Um, how would I answer this one? Because I haven't explained Noah, right? Basically, well done for 8 people who answered this correctly. So Noah basically mean not or, right? So you can think of it as negation outside and then A or B. So basically, this one is the correct one. Not, I don't know. I could give this a because it's not, but it doesn't say that not what, not A or not B. But I gave this solution to Noah. Okay, so next question. But I think that if you answer not because it that doesn't specifically tell you which one you are not to, like either not TV comedy show or not TV police, TV show with police. So, but this one is more correct, like Noah. So it's not or. right? So you can have the or inside. So negation of A, no B, negation of TV comedy show, no or TV show with police. Right? And the last one, if I don't like peas, no. Do I like honey? Do I like peas with chips and no honey? Okay, so the leaderboard, a little bit of swap. So this one's only people who, this one hard because I don't think this one hard because of the logic. This one hard because of the English, right? So it's say if I don't like peas and nor do I like honey. So basically, I don't like peas and I don't like honey, right? So do I like pea with chips and no honey? So basically, the answer is no, because I don't like pea, right? Nor do I like honey. So he doesn't like both. He doesn't like pea and he doesn't like honey. Even though the second part is asking, do I like peas with no honey? But still there's pea there. So the answer is no. Yes, well done. Okay. Um that's it. Okay, let's summarize the winner a little bit. Give a credit to the winner today. Um summary. So third place คุณกสิดิตครับมาร์ค too fast เอาอ่าผมเลยไม่เห็นนะอ้อมเนี่ย so third place คุณกสิดิตนะครับแล้วก็ the second place คุณมันนภัทรนะครับthe first place คุณไกด์
Me,
what's
it's
that
me.
first name อะไรนะครับ
Tiladet.
คุณไกด์ please provide me your ID number can you type in the chat
Okay.
please but I'm not sure what's that mean the symbol the symbol on your first question I don't even know what it is. So okay, most of you well done some of you just kind of gave up, right? Or maybe you log into
I forget to participate the first question though.
okay, that's fine. Well done. Okay, um thank you. I think that's it for the quiz. Let's come back and summarize today's lesson. Okay, so the next topic that um, the what do you call it? The next sessions that I'm going to talk about is how to evaluate the truth values of some sentence. Okay, which is similar to the question that you just had from your quiz. Okay, so if you have a sentence, do you want to know whether it's true or false, right? Because that's all you want to know, right? That's the main important thing. That either if this one is true, so you can make out some decision based on that sentence. But you know that sentence is false, you can also make another decision that related to that truth value of that sentence. Right. So how do you evaluate the truth value? Okay, we can do is using truth table, which is something similar to that one, to this one. Right. For example, you want to evaluate some long sentence. The first thing you should do is to convert the long sentence, the compound sentence, into a symbol like this, and then you can create a truth table using the the symbol here. Yeah. So the excuse me. So the rules of how you create a truth table is, first you want to look at how many atomic proposition in your statement. Okay. For example, this example, if you look at it, you can see that there are two atomic proposition in this example, right? P and Q, right? That's the atomic, but they are just joined it with or with and with imply, right? so if once you know the number of atomic proposition, you can immediately know like how many rows of your truth table there will be. So basically it's just two to the power of the number of atomic proposition that you have. Right? For example, this one you have two atomic proposition. So the number of rows that you will have, not including the header, but including the header, will be four, right? To the power two, four. And that's all you need. That's all you need. So basically I would put the atomic proposition in the first and second and third and fourth columns. And then I will list all possible outcome of each atomic proposition. So P, if you have only two, you can do like PQ, and then P you do like true, false. Q you will do like true, false. If you have three of them, let's say R, you have to do true, false, right? And this one will be true, false, true, false. This one will be true, false, something like this. I think you probably have learned this back in your high school day, but still I want to make sure that you remember this. Believe it or not, like a few years ago, somebody, well, not just some, a few people doesn't remember how to write a truth table, and the order of how to put this true, false, please do not like do it like a random. Please do it like in a pattern, like or true or false, and then true, false, true, false, like this. And because it's hard if you do it in a random, it's hard to, when you put it in like in the exam, like, it's really hard to grade those. Okay. So other than that, you can add little by little, so that the final column would be your position that you want to find the truth value. So this is the truth value of this one. As you can see, there are some case that this proposition is false, and there are some that are true. Okay, so you can find it using the truth table. Okay, I think I'm gonna stop here. Okay, so today we started with the topic of logic. Okay, I'm gonna try to apply a lot of real world examples as much as I can. Okay, the important thing in this topic is that you know how to construct a logic system. Okay, so let's say you have statements or you have sentence in Thai, in English. How do you check the truth values, or how do you um, the important topic will be like really at the back. This is this one. Okay, this is the most important one, because the final um, result that we want to do is to be able to do is how do you argue, how do you make argument. Argument is something that you want to know, you have a conclusion, or you don't have a conclusion, but you have something that you know it's true. Okay, you know something are true, like today is Wednesday, I'm wearing a black shirt, I'm sitting on a chair, something that are true. And then you want to conclude something that also true according to all the statements that you know is true. That is what an argument is all about. Okay? So, and you use a lot in your everyday life. Your argument to be, you maybe you argue what to eat today you argue which laptop you want to use or which laptop I want to buy or something. That's how logic is being used. Okay. Any question for today? อันนี้ก็ จะพยายามไม่เน้นทฤษฎีมากนะครับก็จะเป็นพยายามที่จะเป็น apply ซะเยอะเนาะมิดเทอมนะครับเนาะวันเสาร์นะอุปกรณ์ที่ต้องเตรียมก็แล็ปท็อปนะครับแล้วก็แล็ปท็อปที่เปิดกล้องได้นะครับเพราะจะให้เปิดกล้องตลอดทั้งการสอบ
เสาร์ที่11นี้ใช่ไหมครับ
ใช่ครับ9 โมงถึงเที่ยงนะครับ9 โมงถึงเที่ยงเป็นออนไลน์แปลว่า จะต้องมีการเป็นข้อสอบที่อาจจะต้องมีการเขียนเนาะอาจจะต้องมีการเป็น multiple choice ก็อาจจะมีนะครับเป็น short answer ก็คือ multiple choice เลือกจากระบบเลยนะครับแล้วก็ short answer ก็คือพิมพ์จากระบบเลยและอาจจะมีแบบที่เป็นคำถามที่จะต้องแสดงวิธีทำครับเพราะฉะนั้นอาจจะต้องเตรียมนิดนึงว่าถ้าเป็นแสดงวิธีทำเนี่ยเราจะทำยังไงส่งเนาะเขียนบนกระดาษถ่ายรูปแล้วอัปโหลดส่งหรือจะทำบน iPad แล้วก็สแกนแล้วก็ export ส่งเตรียมไว้ตรงนี้ด้วยนะครับแต่ว่าไม่ใช้ปากกาดินสออะไรนะครับไม่ต้องใช้นะครับสอบอยู่ที่ออนไลน์นะครับ เราจะประจำอยู่ที่บ้านที่ไหนก็ได้แต่ว่าขอให้มีอินเทอร์เน็ตนะวันนั้นถ้าใครมีปัญหาเรื่องอุปกรณ์ฮาร์ดแวร์อะไรแจ้งผมล่วงหน้าไว้ก่อนนะครับเพื่อจะมีสอบซ่อมนะครับดีนะครับถ้างั้นวันนี้ก็ไม่มีอะไรเพิ่มเติมนะครับเดี๋ยวมีอะไรเพิ่มเติมผมจะไปแจ้งในคลาสรูมทีเดียววันนี้thank you for today. I'll see you next week. I mean see you on Saturday.
ครับขอบคุณมากครับ
ขอบคุณครับ
ขอบคุณค่ะ